In the beginning, there was darkness, and then, bang, giving birth to an endless expanding existence of time, space, and matter. Now see further than we've ever imagined, beyond the limits of our existence, in a place we call the universe. Lurking in the shadows of the solar system are worlds so chemically active and misshapen that they border on the bizarre.
I think the most shocking thing was how very different the solar system is.
These are the moons surrounding the planets of the solar system. Moons that were once either unknown or considered afterthoughts are now on the cutting edge of astronomical exploration.
What was surprising, that they all didn't look like our moon. The so-called minor members of the solar system are not of minor interest.
What surprises await us on these alien moons? Our solar system has always been fertile ground for science fiction writers. But with exponential advances in telescopic technology and close encounters by unmanned probes, the curtain has now been lifted on a new ballet of moons.
Most of which are going one way around, some of which are going the other way around, all at different rates, passing one another, the inner ones passing the outer ones.
For nearly half a century, it was believed the solar system was home to only 32 moons. They ranged in size from Jupiter's moon, Ganymede, larger than the planet Mercury, to small asteroid-shaped ones like the Martian moons, Phobos and Deimos. That number has exploded. In 2007 alone, scientists announced the discovery of 20 new moons around Jupiter, 1 around Saturn, and 3 around Neptune.
What happened is astronomical telescopes had available to them what are called CCD cameras. So these are digital cameras that almost everybody has nowadays.
It's difficult to hold astronomers to an exact number of moons in the solar system. As cameras become more sensitive and telescopes more powerful, more moons reveal themselves. Moons are classified in 2 distinct ways. Those, like our moon, travel in nearly circular orbits above their planet's equators and are called regular moons. While our moon formed from an impact, all other regular moons coalesced from the gaseous stew surrounding their parent planets, a process known as accretion.
The classic example of regular moons would be the Galilean moons of Jupiter: Io, Europa, Ganymede, and Callisto. The material that is going to form Jupiter too, but extended a little bit, that material accumulates into the moons.
Moons that follow elongated orbits, highly tilted to their planet's equators, are called irregular moons. Most of these move in retrograde orbits, clockwise if their planet rotates counterclockwise. Phoebe, the newly discovered moon orbiting Saturn, is a perfect example. She began her celestial life as an independent traveler, orbiting the Sun before being captured by the more massive Saturn. Whether regular or irregular, moons must fall within the gravitational reach of their parent planet. The limit of these orbits is known as the heliosphere. This phenomenon is named after George William Hill, an American astronomer from the mid-1800s.
So a heliosphere is this region around the planet that moves along with the planet, inside of which the gravity of the planet overwhelms the gravity of the Sun.
The moons of Mars, Deimos and Phobos, operate very differently within the heliosphere.
If the planet is rotating faster than the moon it orbits, like Deimos, the tidal forces between the two actually shove Deimos out further and further. Phobos, on the other hand, is rotating faster than Mars rotates.
These small moons were discovered by American astronomer Asaph Hall in 1877. He named Phobos after the Greek god of fear and Deimos for the god of terror. Tom Duxbury was part of the Mariner 9 mission that first photographed the two potato-shaped moons in November of 1971.
This was late at night in a cold, rainy, dark, dreary day, and I looked at this and I turned the picture sideways. It looked like a skull. And it was such an eerie thing.
Phobos is in a death spiral. It orbits just 3,700 miles from the Martian surface, closer to its host planet than any moon in our solar system. If our own moon were as close to the Earth as Phobos is to Mars, it would look 20 times larger.
Its orbital period would be in hours, not days like it is now, but hours. And at full moon, it would fill the sky.
The daily tides, would rise and fall tens of feet, if not hundreds of feet. And so the Earth's moon would eventually crash into the Earth in such a situation.
Phobos's predicament is caused by a process known as secular acceleration. As Phobos races faster than Mars rotates, a tidal bump is raised on the Martian surface. In the process, Mars yanks Phobos closer to its surface with each orbit. The struggle between Mars and Phobos is similar to the dynamics of a simple game of tetherball. Imagine the ball as the moon, the pole as the planet, and the rope between the pole and the ball as the planet's gravitational pull.
What we see is that the gravity would pull the moon in such a way that it speeds up. It goes faster and faster, and it works its way until it eventually hits the pole. That's exactly what's happening to Phobos. Phobos is going around Mars faster than Mars rotates. That tidal interaction is pulling Phobos in closer and closer and speeding it up in its orbit. In about 50 million years, we expect Phobos to be pulled in so closely it will impact Mars and disappear as a moon of Mars. On the other hand, Deimos, the further out moon, is going slower than Mars rotates. And so it's unwinding the string in the opposite way. And what we see is Deimos is going further and further away from Mars. And eventually, Deimos will be pulled away from Mars by the gravity of the sun. So over time, Mars will become moonless.
Because Phobos outpaces the rotation of Mars, it appears to rise in the west and set in the east.
Instead of the planet turning quickly under it like our moon and most other moons, and thus having it rise in the east and set in the west, it races ahead of the rotation of the planet, and so it comes up on the western horizon and races ahead and sets on the eastern horizon.
It will be another 50 million years before Phobos completely disappears. Before then, it may prove useful for the eventual colonization of Mars. Science fiction writer Arthur C. Clarke speculated on this idea in his book, The Sands of Mars. Although there is no real reason to colonize Phobos itself, its close proximity to Mars makes it a natural way station.
From a gravity standpoint, it's much easier to go to Phobos, which has no gravity, than it is to fight the gravity of Mars to get down to its surface.
From Galileo to Stanley Kubrick, the giant planets of the outer solar system have tantalized our imagination with their enormity. But in reality, exploring them is tantamount to suicide. The overwhelming pressure from Jupiter's massive atmosphere would make it almost impossible to function. But the moons of these behemoths may provide a more promising platform for exploration and even future colonization. Are these prisoners of Jupiter's gravity, hostile worlds with little chance of sustaining organic life? Or might they provide a safe haven for future generations of planetary explorers? Until recently, very little was known about the moons of the gas and ice giants. Most of them remained hidden in the glare of their parent planets. Today, modern telescopes and unmanned space exploration reveal a realm populated by a host of moons, from planet-like spherical worlds to misshapen ones barely 30 miles across. Jupiter, the largest planet in the solar system, is a moon magnet. Nearly 4.5 billion years ago, it began as a massive gas cloud collapsing in on itself. This process, known as accretion, formed the beginnings of the Jovian system. While nearly all the gas and spinning material went into forming Jupiter itself, a very small percentage clumped in small eddies within Jupiter's orbit. These miniature accretions solidified into Jupiter's regular moons, Io, Europa, Ganymede, and Callisto. As Jupiter coalesced, its massive gravity began adding to its menagerie, little remaining bits from the birth of the early solar system.
The giant planets formed early in a gas-rich environment when there was lots of little flotsam and jetsam around the solar system still to be captured into orbit.
The number of Jupiter's moons ranges from 60 to over 200, depending on who's counting. What's clear is, if you could stand at the edge of Jupiter's gaseous atmosphere and look to the heavens, you'd see a magnificent dance of lunar objects.
It would look pretty cool to be able to see the moons. Every so often you'd see Io come by. Every second time Io comes by, you'd see Europa at the same time. And every 4 times Io comes by, you'd see Ganymede.
One member of this Jovian cast is so battered by Jupiter's great mass that it's literally bursting from the inside out. In February of 2007, the New Horizons spacecraft, eventually bound for Pluto, focused its cameras on Io. About the size of Earth's moon, it orbits 263,000 miles from Jupiter's surface. What sets Io apart from the other Jovian moons is its spectacular volcanism. New Horizons cameras captured detailed photos of glowing lava scattered across Io's surface. A huge 200-mile-high dust plume rose above the surface of the molten moon. Io, like all Jupiter's regular moons, is named after a lover of the god Jupiter from Roman mythology. It was discovered by Galileo in 1610, first photographed by Pioneer 1 in 1974, and again by Voyager 1 in 1979. Its pulsating activity has puzzled and intrigued scientists for decades.
Leaving Io is about a ton per second of material. Every second of every day. It's a phenomenal machine.
I would like to go to Io, even though it'd be very dangerous and hot and sulfurous.
Io is too small to have maintained a molten core since its formation. Another mysterious process must be responsible for its heating.
Io's entire interior may be molten because it's squeezed so much as it's orbiting around Jupiter.
This process is known as tidal heating. The massive gravity of Jupiter is causing friction at the inner core of Io. Much like a sculptor needs a cold lump of clay, Jupiter is endlessly creating its own masterpiece.
If a moon gets a little bit of tidal heating, it becomes malleable. It can be stretched out like clay and deformed by the gravity of the parent planet. The surface of the moon is cold. It breaks, like pulling clay apart quickly. It'll break. But the interior, where it's warm, can literally flow and stretch and be kneaded by the gravity of the parent planet.
Most regular moons have circular orbits. To produce tidal heating, a moon must be in a more oblong orbit, where the distance from the host planet changes radically during a single revolution. The only way to produce these eccentric orbits is if another moon's gravity disrupts it.
When a moon is in an eccentric orbit, a non-round orbit, it gets closer and farther from its parent planet. When it does, it gets squeezed, it gets pulled apart when it's closer.
Io is in orbital resonance with its companion moons Europa and Ganymede, while Jupiter and Io struggle to find a synchronistic relationship. Europa and Ganymede are yanking Io in opposite directions. Jupiter yanks back, and Io gets stretched and squeezed in the process. The tidal heating on Io, which is responsible for its prodigious volcanoes, has a secondary side effect. It creates the largest stationary visible object in the solar system, a massive gas cloud 500 times the size of Jupiter. In 1990, Professor Michael Mandillo and his team from Boston University discovered a large gas cloud spanning the huge distance from one side of Jupiter to the other. They were the first to photograph the entire nebula, discover its origins, and the mechanism that keeps it growing.
Now, Io is small, so it doesn't have much of an atmosphere. But these volcanoes are continually providing material that could be an atmosphere. But you might ask, well, why isn't have a tremendous atmosphere if all the volcanoes have been going on for eons? Well, it's because the material escapes.
The key gas is sodium. Even though it only makes up 5% of Io's ejected materials, it's easily detectable by telescopes on Earth. Sodium emits an orange glow. In fact, sodium is commonly used to illuminate streetlights in many cities across the world. The sodium and the other gas molecules are pelted by light from the sun and electrons in Jupiter's powerful magnetic field. Electrons and protons are knocked off some of these particles and ionized. Now in plasma form, these ions are taken on a ride by Jupiter's powerful magnetosphere. Its speed increases dramatically because it's been picked up by the magnetic field. It's like they're taking a ride on a cosmic carousel.
The magnetic field lines are the holes here, and then every now and then, a sodium atom gets picked up along with its an electron. And now I'm in the Jupiter plasma torus with all the other ions and electrons that have been captured previously. And the ions and the electrons recombine, the neutral is not confined by the magnetic field, and it goes off at a much higher speed. And that's enough to escape from Jupiter. And they form the largest visible cloud of gas that's permanently in the solar system.
If we could see the nebula with the naked eye, it would be the size of 12 moons in the night sky. It is so enormous that to view it, Mandillo and his team created their own specialized telescope.
Well, as it turns out, to get a big field of view, all you need is a small lens, like a pair of binoculars gives you a big field of view.
Even in 1991, the telescope may have seemed ordinary, but its camera was highly sophisticated and, at the time, revolutionary. The digital camera.
Well, once you've got a picture that's in numbers, you can do all kinds of things with it.
Mandillo and his team knew that sodium existed in the nebula. Sodium also exists in the Earth's atmosphere. They were able to compare digital photographs of both Jupiter and Earth's atmospheres and bring forth an image of the nebula.
Well, that was very difficult to do if you just had 2 photographs and pieces of paper. But now that we have these digital cameras, we've revolutionized the way that we can process images.
Though Io would be a fascinating scientific and aesthetic destination, its hostile environment probably precludes that. Even landing an unmanned probe would be difficult among Io's convulsing fissures. But there's another moon orbiting Jupiter which may not only support human exploration, but possibly support its own alien life forms.
Europa is one of the most fascinating and enigmatic objects in our solar system. Really unlike any place else in the solar system, and for that matter, unlike anything on Earth.
The surface features are such that there are cracks in the surface, there's mottled terrain, there's chaotic terrain, and it looks like icebergs in some areas.
We know Europa is an alien moon. Could it be home to alien life forms as well? Europa orbits 400,000 miles from Jupiter's surface, about double the distance of Io. And like its convulsive cousin, it too is molded by gravitational tides. Jupiter has the greatest effect. Its mass, like a persistent lover, pulls the reluctant moon toward its surface. Europa resists with its own gravity, and they form a kind of symbiosis, hundreds of thousands of miles above the gas giant. But it's not just Jupiter tugging at Europa. Little Io and larger cousin Ganymede pull at Europa from different directions. It's the same orbital resonance that has such a dramatic effect on Io. However, the results are far different on Europa. Europa's surface is cold, minus 550 degrees Fahrenheit in some places. Yet there is heating. And what rises to the surface of Europa is also what makes the moon so exciting. Water. This water, actually a kind of glacial ice, is rising from an underground ocean and oozing out onto the surface, repaving it as a Zamboni does an ice rink.
Europa's ocean is thought to be shallow, only about 10 or 15 miles below the surface.
Water was the cradle of life on Earth. Could the same be true on Europa or other moons?
Icy satellite oceans could be the most common habitat that exists in the universe. Earth's might be relatively rare, but icy satellites are probably plentiful.
In February of 2007, the New Horizons spacecraft, on its way to Pluto and the outer reaches of the solar system, managed to fly close enough to Europa to send back some startling pictures. Seen only as the sun is rising or setting behind Europa are enormous geological patterns that have been dubbed crop circles.
They are very large. If you were to, try to drive across one of the circles, you would very, gently go in and travel down to a location that's a few hundred feet lower than the surface you came up from, and then rise back up.
The resemblance of Europa's crop circles to the mysterious ones that dot the countryside here on Earth ends when you consider their size. Each one is 2,000 to 3,000 miles in diameter. They're too shallow and uniform to be impact craters. Asteroids and comets come in different sizes and shapes. Europa's crop circles are remarkably similar geologically. Although nothing has been proven, it seems the great mass of Jupiter may once again be the culprit. The speculation is that the icy covering surrounding Europa is not tethered to the core of the moon. Rather, it's floating above the subsurface ocean, like a spherical iceberg. The polar region may be somehow shaped by Jupiter, and then over hundreds of thousands of years, slowly tugged toward the equator. This forms a line of small circle depressions dropping from the polar region toward the equator. If Europa's ice crust has similar structure to icebergs on Earth, most of it would be under the ocean's surface. This has huge implications for future exploration.
It means there has to be something like 8 or 9 times that amount of ice underneath them to allow that kind of large-scale topography to exist.
The iceberg theory lays to rest the belief that Europa's subsurface ocean can be easily tapped through a thin crust. Radar mapping and ultraviolet data will prove to be even more important before a Europa lander can make its way down to the surface. Future explorers will have to search out hotspots and places where this mysterious ocean has welled up through the surface, and from there try to find a way to dip into it. Those explorers may choose instead to set up a base of operations on Ganymede, Jupiter's largest moon. As Phobos might serve Martian exploration as a way station, Ganymede might do the same for the Jovian system. Larger than the planet Mercury, its gravity is closer to that of Earth's than any of Jupiter's moons. And though it's in orbital resonance with both Io and Europa, it's far enough away from Jupiter to be less affected by the gas giant's relentless tides.
And at Ganymede, you could say, park in some nice big crater and build your domed, protected region, protected from the charged particles in the Jovian system, and make a pretty safe place to study not just Ganymede itself and its magnetic field and its interior and its geology, but the Jupiter system as a whole.
Ganymede is the only moon in the solar system with its own magnetic field. To have this distinction, Ganymede must have sufficient mass and a hot inner core. Its mass is obvious, but where the heat is coming from is a bit of a mystery. Ganymede is affected by both Io and Europa's tidal forces, but measurements on its orbit indicate that it's round enough to avoid the squashing and stretching that its smaller cousins endure from Jupiter.
So the thought is maybe something happened in Ganymede's past to change its orbit slightly, and maybe its eccentricity got kind of haywire for a little while and generated a lot of heat within Ganymede, caused the core to be hot. We don't really know.
What we do know is that New Horizons' recent flyby of the Jovian system gave us a tantalizing glimpse at the wonders that await us on Jupiter's alien moons. Scientists look forward to the day a lander touches down on one of these moons and starts to uncover the secrets of these mysterious worlds. Another icy moon orbits the gas giant Saturn. It's too small to hold onto its own atmosphere, but that doesn't stop it from sapping the atmosphere of its parent planet. Enceladus, even though quite small, is named after a tribe of giants in Greek mythology. Like Io and Europa, Enceladus has an eccentric orbit around its parent planet, Saturn. The tidal forces of Saturn squeeze and knead this tiny moon and create heat at its core. But unlike Io, it doesn't regurgitate molten material that coalesces into a massive gas cloud. Water doesn't well up to the surface as it does on icy Europa. No, Enceladus actually spits plumes of icy water into the atmosphere of Saturn.
So we don't call it a volcano, it's more like a geyser. The water vapor is then in orbit around the little tiny moon, or because it's near Saturn, Saturn's gravity can pull it into the planet.
Interested by their work on the torus of Io, Michael Mandillo and his team at Boston University began to consider Enceladus's effect on Saturn's atmosphere.
And it turns out that water is a wonderful catalyst to have the ions and electrons recombine.
Before Cassini, scientists relied on computer models to determine atmospheric conditions surrounding Saturn. They indicated that Saturn should have a very robust ionosphere. Surprisingly, Cassini's data indicated that Saturn's ionosphere was only 10% of what computer models had predicted. It seems that the icy water ejected from Enceladus is neutralizing the charged particles in Saturn's ionosphere.
Commit. Liftoff.
Scientists had learned, quite by accident, the effect water can have on Earth's atmosphere.
In 1973, when NASA launched its Skylab workshop, it launched its last gigantic Saturn V rocket, the moon rocket. And it had never had a launch that allowed the space vehicle to keep its engine burning as high as the ionosphere. Well, this gigantic engine dumped a ton per second of water vapor, which comes out of a giant rocket motor, into the ionosphere. And the ionosphere nearly vanished on that day.
It blew a gaping hole in Earth's ionosphere, the top layer of the atmosphere. A hole that took the sun's ionizing radiation 24 hours to repair. However, on Saturn, where Enceladus continuously dumps 6 tons of water per minute into its atmosphere, the long-term effects have been significant. There's no worry that Enceladus will strip away its parent planet's ionosphere completely, but this tiny moon, only 300 miles in diameter, has gotten the attention of the scientific community and Saturn itself. While we prepare probes to Phobos and Europa and study data from Enceladus and Io, an entirely new set of moons has literally just come into the picture. Before the 1990s, most astronomers agreed that there were only 34 moons in the solar system. Most of those were regular moons like our own, spherical bodies that orbit their host planet in the same direction it rotates. But a handful of these satellites were what's known as irregular moons. These freakish moons follow elongated orbits. Their orbits are often tilted, and they rotate in the opposite direction of their host planets.
They look like flying potatoes or splinters or misshapen lumps.
They've been hard to find before now because they're very small and they're also usually very dark.
The advent of digital photography and the use of light-sensitive optics changed the lunar terrain within a decade. Dr. Brett Gladman from the University of British Columbia discovered his first irregular moon in 1997 at the Palomar Observatory. Since then, Dr. Gladman has brought to light 17 previously hidden objects in the solar system.
So you detect objects in the outer solar system by observing them move relative to the background stars and galaxies, which are stationary. So if you take a picture of the sky and you wait an hour and you take another picture of the sky, none of the stars and the galaxies will have moved, but distant objects in the outer solar system will displace by a visible amount between the two pictures. And so by comparing the two pictures, you can see, as we have here, a moving target.
The object could be a comet or an asteroid, or, if it orbits a planet in a retrograde fashion, a new irregular moon. Another important distinction between regular moons and their irregular counterparts. Irregular moons are captured. That is, they formed independently of their host planet and most likely were part of the debris that originally formed our solar system. Phoebe, the largest irregular moon orbiting Saturn, is a classic example.
Phoebe orbits Saturn very far out. It has a very elliptical and very inclined orbit. It orbits in a retrograde direction. Voyager images suggested that this thing looks like it could be an asteroid, and so people thought maybe it is a captured asteroid. Now we know from Cassini it's a very water ice rich body. That pretty much rules out the asteroid belt. The thinking is that Phoebe could very well have come from the Kuiper belt, way out in the outer reaches of the solar system.
The Kuiper belt is thought to be the debris left over after the solar system formed. It revolves around the sun beyond the orbit of Pluto. However, another theory suggests something altogether different.
It's much more likely that Phoebe formed in an independent orbit around the sun and then was captured into orbit around Saturn, whereas most of the other objects that formed near Saturn's distance were either accreted by Saturn or ejected from the solar system.
Phoebe would then be made of the planetary debris that was floating around Saturn at the time of its birth. And possibly, it's made up of different material than some of the irregular moons orbiting Jupiter. If this is the case, astrogeologists may be able to discern and compare the different ingredients that birthed these two gas giants. Three main theories currently exist as to how Phoebe and its other irregular counterparts lost their independence. Two suggest the irregulars were captured as the solar system was still forming and the planets were still an accreting blob of gas and debris. The gas drag theory is the most straightforward. Thick gases were swirling around the accreting planet when a comet, asteroid, or a shattered combination of both passed through the gaseous mixture.
We know that the giant planets built their regular satellite systems in a large accretion disk around each of the planets, sort of like a mini little solar system forming around each planet. And the gas and dust that was in that disk can also serve in its outer regions as a source of friction where passing planetesimals formed independently are slowed down a little bit and captured into orbit.
The second theory is really a variation on the first. It's sometimes called the pull-down theory. Here, instead of an object being caught by simply passing through the accreting gases, it is unsuspectingly pulled into the forming planet's orbit by its growing gravitational pull. The gas drag and pull-down theories of capture work well for both Jupiter and Saturn because their mixture of ingredients was massive enough to slow down these passing objects. But what about the icy giants, Neptune and Uranus? Because of the extreme cold, they formed much more slowly, and it's difficult to believe that their icy accretion mixture contained enough mass to snare a passing piece of the solar system. Yet both icy giants have their own irregular moons. Hence a third theory, three-body interaction.
We discovered that many of the objects are actually more than one object. They're usually two objects often, that because they're both more or less the same size as the other in a binary relationship, instead of being a big object with a small object going in orbit around it like this, it's two more or less similar sized objects going around a common orbit. Between the two of them is called the barycenter.
A binary pair exists when two objects of the same size are tight enough to the barycenter to prevent a third larger object from splitting them apart. But when one of the binary pair is significantly larger than the other, the more massive third object has a greater chance of separating them.
The smaller one will tend to have the much bigger orbit swing out further.
This brings the smaller object close enough to the planet to be captured, while its partner is slung out into an independent orbit. One bizarre moon seems to defy classification. Triton orbits Neptune in a retrograde fashion, counter to Neptune's rotation. That would make it an irregular moon, except that it's spherical and orbits close to the equator, with an almost perfectly round circumference, a classical description of a regular moon. It also spews out mysterious icy plumes, with some indications that it once was, or possibly still is, volcanically active. Before Voyager 2 ventured into the outer solar system, Neptune's moon Triton was assumed to be a geologically dead ball of rock about the size of our own moon. When Voyager beamed back photographs revealing a world with mountains, fault lines, and fissures indicative of tectonic movement, as well as a surprisingly thick atmosphere, scientists were amazed. Geologic forces, usually associated with much warmer and larger planets, might be occurring on a frozen moon slightly smaller than our own. Voyager detected no active volcanoes in 1989. However, like Saturn's moon Enceladus, geysers periodically erupted from the planet's surface. What's really stunning about Triton is not just that it has some unique geological processes occurring, but the fact that they're happening even though Triton is an irregular moon.
Most large moons in the solar system are regular satellites, with the very important exception of Triton, Neptune's largest moon, which orbits the wrong way. So Triton is thought to have been a captured object.
A captured moon that acts like a regular one. How did an object the size of Triton slow down enough not to either pass through Neptune's atmosphere or collide directly into the icy planet? There's no sure bet, but some theories carry better odds. Much like gamblers at the roulette wheel, Triton and Neptune played the odds and trusted to luck.
Place your bets, get lucky now.
In roulette, there are several ways to bet. Each one carries different odds, and like most games of chance, the longer the odds, the greater the payoff.
20 black even.
There are at least 3 possible ways Triton could have been captured by Neptune.
All 3 hypotheses are physically possible, but the first one, the idea of gas drag, is the least likely simply because the period of time in which Neptune had a disk of gas and dust which could have captured a proto-Triton object was a very short period of time, and so the window of opportunity was very small. So that's like betting on the green 0 on the roulette table. More likely is the possibility that the proto-Triton sometime in solar system history crashed into a set of regular middle-sized icy satellites, and it was the collision which gave us Triton. And that's like betting on the first third of the numbers on the roulette table, so you have like a 1 in 3 chance of that taking place. Your best bet is to bet on the even numbers. There you have a 1 in 2 chance of things happening, and the best bet for the capture of Triton right now is this binary capture hypothesis, because there we know there are probably thousands of objects that have existed in the Kuiper belt that would have the right size and be partnered with another even larger object, and Neptune could capture one of them.
No one knows for sure which number paid in the early days of the solar system when Neptune captured Triton. However, once Triton began orbiting Neptune in an irregular fashion, it started obliterating anything that got in its way.
Neptune doesn't have a very regular system of satellites. It's thought that the capture of Triton disrupted what would have otherwise been a nice regular system like the other large planets have.
It's as if Triton was angry at losing its freedom and took it out on Neptune's other hapless moons. But where did this headstrong moon come from? Data from Voyager 2 indicates that Triton's density nearly matches Pluto's. This suggests a kinship that no other regular moon can claim. It's suspected that Pluto and Triton are both objects that originated in the Kuiper belt.
The outer solar system consisted of these large objects going every which way, essentially. Some of them formed the giant planets themselves, and some of them were tossed out further, where they sit today in the Kuiper belt.
Collisions, accretions, and even captures have diminished what was once a major thoroughfare of planetary building materials.
Early in solar system history, the Kuiper belt had far more larger objects that may have once had a cumulative mass of 50 Earths, whereas the current Kuiper belt mass is much less than 1 Earth.
What's left of the Kuiper belt is as old as the solar system itself. The material that makes up the binary objects, shards of collisions, and even some alien moons hasn't changed in over 4 billion years.
It's amazing how really different all the moons of the outer solar system are. When I first got interested in astronomy as a kid in the 1960s, we hadn't seen any of these moons. They were little dots in your telescope, and so we had no idea how radically different they could be. I think the most shocking thing was how much variety there is in the solar system. I think that blew me and everybody else away who lived through that period.
As we travel back home from the frigid outskirts of our solar system, awed by the vastness of the universe and the majesty of the planets, it's worth it to pause and take notice of the small worlds in the shadows. Those alien moons that were once considered afterthoughts hold mysteries just waiting for human curiosity to solve. In the beginning, there was darkness, and then, bang.
giving birth to an endless expanding existence of time, space, and matter. Now see further than we've ever imagined, beyond the limits of our existence, in a place we call the universe.
Lurking in the shadows of the solar system are worlds so chemically active and misshapen that they border on the bizarre.
I think the most shocking thing was how very different the solar system is.
These are the moons surrounding the planets of the solar system. Moons that were once either unknown or considered afterthoughts are now on the cutting edge of astronomical exploration.
What was surprising, that they all didn't look like our moon. The so-called minor members of the solar system are not of minor interest.
What surprises await us on these alien moons?
Phobos, on the other hand, is rotating faster than Mars rotates.
These small moons were discovered by American astronomer Asaph Hall in 1877. He named Phobos after the Greek god of fear and Deimos for the god of terror. Tom Duxbury was part of the Mariner 9 mission that first photographed the two potato-shaped moons in November of 1971.
This was late at night in a cold, rainy, dark, dreary day, and I looked at this and I turned the picture sideways. It looked like a skull. And it was such an eerie thing.
Phobos is in a death spiral. It orbits just 3,700 miles from the Martian surface, closer to its host planet than any moon in our solar system. If our own moon were as close to the Earth as Phobos is to Mars, it would look 20 times larger.
Its orbital period.
It's difficult to hold astronomers to an exact number of moons in the solar system. As cameras become more sensitive and telescopes more powerful, more moons reveal themselves. Moons are classified in two distinct ways. Those, like our moon, travel in nearly circular orbits above their planet's equators and are called regular moons. While our moon formed from an impact, all other regular moons coalesced from the gaseous stew surrounding their parent planets, a process known as accretion.
The classic example of regular moons would be the Galilean moons of Jupiter: Io, Europa, Ganymede, and Callisto. The material that is going to form Jupiter too, but extended a little bit, that material accumulates into the moons.
Moons that follow elongated orbits, highly tilted to their planet's equators, are called irregular moons. Most of these move in retrograde orbits, clockwise. Our solar system has always been fertile ground for science fiction writers. But with exponential advances in telescopic technology and close encounters by unmanned probes, the curtain has now been lifted on a new ballet of moons.
Most of which are going one way around, some of which are going the other way around, all at different rates, passing one another, the inner ones passing the outer ones.
For nearly half a century, it was believed the solar system was home to only 32 moons. They ranged in size from Jupiter's moon, Ganymede, larger than the planet Mercury, to small asteroid-shaped ones like the Martian moons, Phobos and Deimos. That number has exploded. In 2007 alone, scientists announced the discovery of 20 new moons around Jupiter, 1 around Saturn, and 3 around Neptune.
What happened is astronomical telescopes had available to them what are called CCD cameras. So these are digital cameras that almost everybody has nowadays.
If their planet rotates counterclockwise. Phoebe, the newly discovered moon orbiting Saturn, is a perfect example. She began her celestial life as an independent traveler, orbiting the Sun before being captured by the more massive Saturn. Whether regular or irregular, moons must fall within the gravitational reach of their parent planet. The limit of these orbits is known as the heliosphere. This phenomenon is named after George William Hill, an American astronomer from the mid-1800s.
So a heliosphere is this region around the planet that moves along with the planet, inside of which the gravity of the planet overwhelms the gravity of the Sun.
The moons of Mars, Deimos and Phobos, operate very differently within the heliosphere.
If the planet is rotating faster than the moon it orbits, like Deimos, the tidal forces between the two actually shove Deimos out further and further.